Hey guys, welcome to episode 4 or lesson 4, focusing on angle, sum, and difference. I'm going to draw your attention to my little drawing right here, my little picture. A sine gerene over a cosine gerene is a tangerine. Anyway, let's jump in to exactly what we are talking about today. So today's topic, or this lesson's topic, is focusing mostly on angle, sum, and difference. So like lesson 3, you are going to start with fractions. You are going to start with multiplying, dividing fractions, and Delta Math has its own embedded video. I will support you in this next section on how to do angle, sum, and difference. And then your third portion of your Delta Math assignment for Thursday is mixed trig formulas. So there's going to be mixed problems that'll give you both double angle problems and angle, sum, and difference. So make sure that you have a good understanding and grasp of both of those things before you jump into that. Otherwise, it's exactly the same. So essentially, the only new thing that we're talking about today is angle, sum, and difference. So let me get my little thumbnail out of the way. Perfect. So angle, sum, and difference has these 4 formulas. This is something that we've done before. So there's sum and difference formulas for the sine function right here, and sum and difference formulas for the cosine function. So like the double angle formulas you did in lesson number 3, if you may use a calculator, all the triangles that you create to solve these problems are positive lengths, and we are doing it based on trig ratios, not angle measures. So conceptually, this is actually very similar to the angle, sum, and difference problems that you have done on your own. However, Delta Math gives the problems a little bit differently, so that's why I'm doing a video to support you and show you exactly how they want you to solve it. But otherwise, it is exactly the same thing. So go ahead and get out your notes. Let's jump into the example problem. So when you are given an angle, sum, and difference problem, you are given 2 angles. Because you are given 2 angles, you are thinking essentially about 2 different triangles, triangle A and triangle B. In the case of the equations that it gives you, same thing. These are just Greek alphabet letters for A and B, alpha and beta. So you're given 2 triangles, A and B, and you are going to use the given information in order to find everything that you need in order to actually plug into these formulas. So this is a problem that's drawn exactly from a Delta Math problem that you might actually see. So you are given cosine of A, and you are given tangent of B. Also notice at the beginning where it's telling you that they're a positive acute angle. You know that they're going to be positive triangles, so you don't have to worry about positive and negative, and you are given 2 pieces of information. And then it's asking you to find cosine A plus B. This is your hint to tell you exactly which formula you should be using. So you want to think, okay, which formula do I need to use that looks at the sum of 2 angles for cosine, right? And you should, right, look at your formulas and then find the one that adds up 2 angles for cosine, which is, bing, 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 that's as close as I could get to the one that I used to use in class. So we are using this formula right here, cosine alpha plus beta. So we're using cosine A times cosine B minus sine A times sine B. So let's go ahead and grab that. So we are given 2 pieces of information. This is a given. Cosine A is 3/5, right? That is part of the problem. So what we want to do now is use that given information to find everything in triangle A. So basically you have 2 triangles, right? Triangle A with angle measure A and triangle B focusing on angle measure B. So let's focus on triangle A and what it gives us. So we know that cosine A is 3/5. We also know, right, thinking about our past assignment, that cosine is adjacent over hypotenuse. So you're literally going to set up a triangle and you're going to think only in positive angle measures. You've got your angle A and you have adjacent 3/hypotenuse 5. Right, so you have these two sides. We want to find sine A as well. We can use this triangle to find everything that has to do with A. So you are going to use Pythagorean theorem to find that last side, or the fact that it's a special right triangle. And you've got 3 and 5, and you're going to find your side length B, your other leg, which will be 4. So then you can use that to find sine. So we already know cosine is 3 over 5, adjacent over hypotenuse. We now also know that sine, opposite over hypotenuse, is 4 over 5. So 4 over 5 is another piece of information that we can plug into our formula when it's time. Let's move on to triangle B. Conveniently, there's given for triangle B as well. This time you're given tangent. So unfortunately, you can't plug in tangent into the formula at all because it's not part of the formula. We are looking for cosine B and sine B. So you're literally going to do the same thing. You know that tangent is opposite over adjacent. So you are going to create your triangle. You've got a triangle right here. You put 7 opposite of B next to 24 adjacent to B. You are going to use Pythagorean theorem in order to find the missing hypotenuse, which is 25. Another one of our lovely special right triangles. So moving on from that, you can use this triangle now to find sine and cosine of B. So take a second, do it on your own. Maybe pause this video, write down what sine and cosine of B would be, and then I'll show it to you. Okay, sine will be 7 over 25, and cosine of B will be 24 over 25. So now you're going to look at your equation. We already have our A triangles. We have cosine of A and sine of A. And we just found, right, sine of B and cosine of B. So we are all good. We've got all of the information that we need to plug into this equation. So let's gather that all into one place. So we've got sine of A, cosine of A. We've got sine of B, cosine of B. I'm just repeating this over and over again so that it starts clicking if it's not. Then you are going to plug it into your actual formula. Anywhere there's a cosine A, you are going to plug in the fraction for cosine A, which is 3/5. Cosine of B, you are going to plug in the fraction for cosine of B, 24 over 25. Sine A, same, and sine B, same. You should get something like this. So you've plugged in all of those values, and now you are going to use the fraction skills that you've been working on all week to solve this problem. First, you are going to multiply your fractions. So you're going to multiply numerator by numerator, denominator by denominator. So go ahead and do that before I show you the answer. So pause the video and do it on your own. You're going to multiply numerator by numerator here, and denominator by denominator here, and same with the second term. All right, I'm going to go ahead and show you what happens when you do that. You should get 72 over 125 minus 28 over 125. And then you are going to subtract your fractions. You're just subtracting numerators. So your final answer is 44 over 125. Hope that helps. Thank you very much.